Okay, line D7, learning task number 2, which is going to be describe hazardous location wiring methods. First learning task focused around being able to describe and identify the areas where we're going to run into hazardous locations. The second one over here is going to go and describe how we are going to go and wire safely inside of these according to our Canadian Electrical Code. First of all, we have to go and take a look at our pieces of equipment themselves, and we have to assess, should I be installing this in this location? Is it necessary for me to go and install a light right here where I've got a, zone 0 type of location, or do I want to go and install my light over there where I've got a zone 2 and install flood lighting to go and light this area up? We also need to go and take a look at the type of equipment it is as well. Is this equipment going to go and cause one of two things that we're always watching out for? Heat, and if so, how much heat is going to be caused by this thing? Or is it going to go and cause any sparks? And once again, if it does cause any sparks, how are those going to be able to possibly be transmitted to the outside? If we determine that our piece of equipment could be producing heat or it could be producing sparks, then we want to be, especially sure of the fact that it's going to be able to contain any sort of an explosion that it might cause through the ignition of any sort of gas or dust that is going to be around it. One of the best ways to go and prevent ignition is to go and use what we would refer to as intrinsically safe and non-incendive. Incendive refers to fire. Incendiary is something that burns. So if I've got intrinsic or non-incendive equipment and wiring, that means it's going to be a type of equipment and wiring that's not going to go and cause heat, flame, or spark. It's going to be very limited. Now, there will always be a small ability to go and create heat, fire, or spark, but it's going to be very, very limited. Even if it is going to be inside of an explosives atmosphere, it's going to go and have only a tiny amount of current it can put out, which means that its arc is hopefully going to be short enough in duration and low enough in temperature that it doesn't cause any sort of an issue. Intrinsically safe systems are specially designed. They're not going to be a regular type of one. You can't just go look at a circuit and be like, yeah, that looks like a good circuit. I'll call that one intrinsically safe. They're going to be manufactured, and usually they are going to go and have a engineered component. And what we'll have is we are going to go and have barrier ring inside of there, or what we refer to as air gapping through here. We're going to go and have a field device. So we'll just draw that out over here. We have a field device. Call that thing FD over here, field device, which is going to go and be in my hazardous location. I'm just going to go and highlight, that's kind of my hazardous location over there. My field device is going to come out of the hazardous location, and once it's all the way out of the hazardous location and the associated, zone 1, zone 2, etc., as it moves its way through, then we're going to go and bring it to some sort of an isolating device. This isolating device is then going to go and isolate it from the other side. Very commonly, we're going to do this through something called optical isolation, where we are going to go and use light to transmit data back from one side to the other. And then that barrier device, we're going to call this one over here, is going to be our barrier device. The barrier device over here is going to be in that non-hazardous location. On this side of the barrier device, we are going to go and have information that we're going to be taking from, whatever this is. Oftentimes, the intrinsically safe are going to go and be the sensors that are going to be placed in stuff. It's not usually going to be lights or anything like that. It's usually just something that we're going to go to read a gas type of process. So we're going to be able to take that all off, and we'll take that to, computers and other stuff, data processing, DDC type of systems, or PLC type of systems that are going to be controlling the rest of our process. We have our dangerous location. We've got this, which can only take in a tiny amount of power through it, and it's hopefully going to go and be safe inside there. And then we just prevent us from having any sort of a dangerous backfeed, short out on the computer that could possibly come through. We do that through that barrier device, which is usually going to achieve that through optical isolation. We'll use them inside of instrumentation most commonly. Equipment is going to have to be rated for explosive atmospheres if we're going to be using them, or for the type of atmosphere that we are going to go and have. We are going to hear quite commonly of explosion-proof enclosures. And all that an explosion-proof enclosure is it is going to be able to go and contain any sort of explosion that happens inside of it. So we are going to go and have to find some way to block this off. We're going to talk about barriering in a minute. but we're going to go and place devices inside here. It could be like a light switch or something like that. That could be spark producing inside of this thing. Once it's got a proper cover over the top of it, we'll just draw that like we got a cover over top. Any explosion that happens inside here is A, not going to be able to go and break it, so we shouldn't get any cracking or anything that's going to go and develop. And B, it should be able to go and leak to the outside. If we have an explosion, we're going to go and have an increase in our pressure. Pounds per square inch are going to go up, which means that it has to bleed out somewhere. And the way we're going to go and prevent it from doing any, or from igniting everything that's outside of this, is we are going to go and force it out over top of long threads or over top of large aluminum plates that are going to go and act as a heat sink for it. They will vent an explosion, but when they vent the explosion, they're going to have cooled the gases before the gases actually go and leave. Explosion proof is also going to be an old rating that had to do with our class and div type of ratings, not so much in the zone ratings. In the zone ratings, we're not looking for stuff that is going to be explosion proof. We're going to look for stuff that is going to go and be flame proof. And flame proof means the same thing underneath the zone type of system. Let's take a look at a class and a div type of rating over here. This is from a piece of equipment over here where it's for a heater actually that's going to be used inside of hazardous locations. And so we've got all of these ratings that are on there. First thing that I'm going to note is that this thing is CSA rated. If it doesn't have a CSA rated rating, I shouldn't even be looking at putting it inside there. And then the second thing I'm going to look at is, since this is the old class and div, what my different types of classes that I can go and have it in. Remember what the breakdown is going to go and be off of these. Class is going to go and be the type. The div is going to go and be the time. So that's actually, class is going to be more so whether it's going to be gas or dust, I should say. Gas/dust. And then the group is going to go and be the actual type of dust, or the type of gas that we are going to go and see inside of here. What I see is that this thing is going to be rated for, I've got class 1, which is going to be gas, it's rated for class 2, dust, and it's rated for class 3, which is going to go and be fibers. And then inside of that, I see that it's rated for div 2, as far as gas goes, so infrequent gas that I'm going to go and have, and it's rated for all of my gas groups. So any type of combustible gas, A, B, C, D, it's rated for, but only infrequently. As far as for dust, I see that's rated for my dust. It doesn't matter whether it's going to be very frequent or infrequent. It's got no time limit off of it, and it's rated for all types of dust, E, F, and G. And then I see for my class 3 that it's just rated for class 3 types of locations. It doesn't even matter what the type of fiber is. It's rated for anything to do with my fibers that I'm going to go and have. That's pretty cool. The next thing that we're going to go and take a look at off of here is that I've got this thing called a temperature rating. So I'm going to go take a look at this. There's two main temperatures that are on here. First of all, I'm going to go and have this, which is going to be my ambient temperature. These things actually have a limit on how cold it can be and how hot it can be. If it gets too cold, wherever this piece of equipment is, the metals that it's made of could contract and create gaps that are going to allow gases or dust inside. If it gets too hot, they could expand too much and lead to cracking or rupturing, particularly of hinges and screws and things like that. What I have is I've got a temperature code T over here. That temperature code T that I'm going to go and have off of here is going to go and tell me how hot something is going to be able to go and get off of that T rating. These are going to be inside of your Canadian Electrical Code, and it's basically going to go and tell you what the surface temperature of this piece of equipment is going to go and be. And you're going to go and compare that surface temperature with what you want to go and place it around. If this thing gets to, a degrees of 120 degrees, does the gas that I'm going to be placing it into, does it cook off at 120 degrees? We've got a whole pile of charts in the back of our tables in J18, as well as inside of our section 18 that are going to go and deal with the different types of gas and what they have got for their incendiary temperatures. That's for what that is. Type 4X is going to go and be a NEMA type of rating. We talked about that in previous videos that, we've got our type 1, type 3, type 3R, type 4X, which is going to go and deal more to do with environmental sealing not for gases so much, but for waters or for dusts or things like that that are going to be inside of it. I'm also going to go and have sometimes other types of ratings that are going to be on here. Now over here, I see I've got a CL1. That is going to be a Class 1, Zone 1, AEXEIIT. This over here is going to be dealing with one of my NEMA types of rating, or sorry, my IEEE types of ratings. There's a couple things that we can pull off of this right away. First of all, we're going to go and have for Class 1, Zone 1, and then we are going to go and have an AEXE. This is going to be explosion proof for the EX over there. The A is, shoot, I forget what the name of that one is. I have to look that one up out of the chart in the code book. Can't pull it up off the top of my head, but it just basically tells us that, you know, the type of enclosure that it is. And then the II over here tells me that it is going to be for group 2, which means for gases, and that T over here is going to go and tell me that it's going to be a type T temperature code. Once again, we're going to be able to pull that out of our code book for these. We will have these ones sometimes rated as well on, you know, zone ratings like this, where we are going to go and have them laid out just bit by bit. And these are all going to be available inside of your code book. The EX, you know, explosion protected. The D, the fact that it is going to be flame proof, which means it's going to not allow flames to go and enter or to leave. The IIC over here, the group 2C, tells us it's going to be usable with gas group 2C. Remember that I have got my A, B, and C types of groups that we had, where we saw that we have got different ones over there. Most hazardous are group C, least hazardous are group A. If this thing is rated for group C, it is also good plus any lower groups. So that would mean group B or group A that would also be good for. T5 is going to be a temperature code. We would find that once again out of our code book there, 100 degrees Celsius. And GB, the enclosure protection level, it offers a high level of protection. All of these different gas groups that we are going to go and see in dust groups, you know, these IIA all the way through to my IIC, which is going to be the high danger and versus my low danger over here. We rank them just for, first of all, you know, the fact that they can go and cook off and cause an explosion, but also for corrosions is another reason why we need to go and have these gas group ratings. Some of our gases are actually going to be more corrosive than others, and so part of the way that they're classed is not only due to flammability, but also due to the way that they can corrode stuff. Temperature, we've covered that one before. Temperature code just tells us how hot this thing is going to get, and if we go into our code book, then we can go and look up and see, well, if this gas is, you know, that I'm going to be using it around hydrogen, is that hydrogen going to go and be cooking off at that temperature, etc. They give you a couple examples inside the book here. T3, you know, it's going to be temperature under 200 degrees. Dust locations are going to go and have them directly marked onto the label, because with dust, we have to always watch for buildup. It's one thing to be rated for, it's another thing if you go and get a fine layer of dust all the way over top of a piece of equipment, because it starts to act as an insulating layer. And then it starts to go up, and there's a greater chance that you're going to go and cause explosion inside there. Anytime that we have got rating, what we see over here, if we've got a high rating, we're also able to go and cascade that piece of equipment down into any sort of a lower type of rating. So if I have got an area that's, you know, is a gas type I2A, I can use something that's rated for gas type 2C. It's overprotected, but when it comes to protection, we'd rather be looking at it than looking for it, because otherwise, you know, you just end up in situations where stuff is going to go wrong. Wiring methods inside of here are also covered as far as our seals and our enclosures. We are going to go and have sealing. That's going to go and happen from component to component. And we can go and get this thing that is going to be called pressure piling. That's going to be caused inside of gas areas, where if I'm going to go and have gas that gets inside of an equipment, and we make the assumption that gas is always going to get inside of our piece of equipment, no matter how we go and seal them. So we're going to start with just the fact that we have got gas that is inside of all of these, just through sealing, through small leaks on the seals, etc. It should be a slow build of gas, but there will always be gas inside of these pieces over here. If that gas builds up to the point where I can go and create this primary explosion, that primary explosion is going to go and pack. It's going to go and pack the gases into the next one. Now we're going to go and have packed gases that are then going to go and explode inside here, which is then going to create a more powerful type of explosion, which is then going to go and super pack into this section over here. They've all had the same level of gas inside of them, but because this section here is super packed, it is going to go and have a really large explosion. And you get this pressure piling that can go and build through the system, pop, 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 as it goes through. And then it is going to eventually be able to go and rupture. Remember, the whole point is that our explosion proof is supposed to go and hold onto all of the flames that are going to be inside of these things. To go and prevent that, the best way to prevent that would be to stop this pressure piling from happening. And so what we're going to do is we're going to go and build a dam. We're going to build a barrier across each one of these before they go and leave, so that we don't end up with any of that pressure piling in between. Usually this is going to be done through something that is going to be referred to as conduit seals, commonly termed as EYSs, because they are just explosion-proof, a Y type of fitting that we have. They look something similar to this. We're going to go and have rigid metal conduit in this place. A lot of times our wiring methods are going to go and be rigid metal conduit. I see that I'm going to go and thread this on. I'm going to have a minimum number of threads that have to be engaged so that I'm going to go and be able to cool any gas that does escape outside of these. And I'm going to go and take all of these. I'm going to fill these things up on the inside. So what you're actually doing inside of here is you've got two things. You've got this little port up top over here. You've also got this main port over here. This main port is going to be sized the same size as your conduit, if not a bit larger. And what you're going to do is you're going to go and place wadding into the inside. It's going to be like a cotton batting that you're going to take in. You're going to shove it in with your finger, and you're going to go and pack it around each of my conductors. Some over there and some over there. All that this does is it temporarily is going to go and hold the sealing compound until I go and place it in. The sealing compound is going to go and come in pre-mixed packs like this. They're not mixed. It's a two-part epoxy, and like all epoxies, it is going to go and cook off hot. Literally, it will go and heat up, and what you do is you kind of squish these two packs together. That goes and ruptures this over here, and then what you do is you kind of mash it around with your finger, squish, 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 back and forth to go and mix it till it's uniform in consistency. You've only got a certain amount of time that you can go and use it as well, and then you can go and squeeze that out. Now, that is for your instant types. Some of our older types were the ones where we had to go and mix them with water, where it was just going to be a powder. You stick them inside of a container, you fill up to a certain line with water, you shake that thing up, and then it forms into this goo that you're going to go and pour in. You take that goo, you pour that thing in, you basically fill this up. Because you place those fiber dams in, and because it's a fairly thick compound, it's not going to go and travel down there. But what happens is this Chico substance is then going to go and harden up. And once it hardens up, it just forms like a cement inside here. You're not pulling anything in, you're not pulling anything out of here. This is the last step as part of a hazardous location. Because once you've got it in there, you can no longer take your wires in and out of it easily. Pack it all in, and away you go. With the fast seal, it's kind of like that polyurethane foam. It is going to go and expand once you go and place inside there, and then it is going to go and cure really fast. When you do have the speed seal type, you're going to go and just dump it directly in. You don't need to go and place the stuff because it's going to be continuously foaming up. It hardens up on the outside as it foams in. So we'll just kind of show it over here. As it kind of foams its way through there, the outside hardens up first, so it's going to go and form a seal there, it's going to form a seal there, and then the rest of this foam will go and cure as well. A couple other glands that we have over here. This is going to be my standard EYS that I see over here. If I do have it in a vertical run of pipe, this thing is going to go and be to the top because you're going to go and use this, the access hole, to go and shove your little bits of wadding in around the conductor and around the conductor. Then you're going to go and replace this plug over here, and then you're going to go and open this, which is going to be the port over here. You're going to pour the Chico in from there. If it is a vertical one on your Chico speed seal, you can go and place just a lower one in, but you do still have to go and place that dam inside there. You're not allowed to just pour the Chico speed seal because the Chico speed seal will still go down into your conduit. You need the lower dam. This over here is going to go and be an elbow that you would use, different to a lot of our other elbows that we have, but same type of idea. You're going to go and have your wires coming, or your conduit coming in, your conduit going out, and then you're going to go and pack the dams and then go and seal that thing in there. At the bottom of this one over here as well, I do want to go and note that we have got a cable. type of fitting over here that we are going to go and use with some of our hazardous location cables, things like my mineral insulated cable or my tech cables that I'm allowed to go and use. Conduit seals are always going to be used anywhere that we enter into a spark producing location or an enclosure. We have to keep them close to it, within 450 millimeters of that enclosure, and as we go from location to location, as we drop out of a 0 into a zone 1 and from a zone 1 into a zone 2, etc., we're going to go and place these conduit seals at each one. Cables are also going to be treated in the same way. Cable fittings for tech type of fittings are going to be done with these special connectors. They're very expensive connectors. This is going to go and be a red ring that you will see off of them, which signifies them as being an explosion-proof type. And what you're going to do is you're going to go and have, it's almost like having two tech connectors. You're going to go and do your main tech connector into here. So you're going to go and strip the outer jacket, you're going to cut back the inner jacket, you're going to have the conductors, you're going to place them through there. And this connector that I have over here actually is a long tube. That's going to go and look like that. That's what this thing is. And I do my actual cable connection into there, and then what I'm able to do is I'm able to take that sealed cable, and because all my conductors come through this tube over here, I'm going to go and pack this tube, and I'm going to go and place my sealing compound. Oftentimes it's going to be like a two-part moldable type of putty, very similar to like plumber's putty, where it's going to go and it actually smells like dog crap. And you just squish the stuff together until it gets malleable, a uniform color, and then you mash it into there and it seals up. And then you take this whole section, which is now a sealed cable, your cable exists out of there, and you shove it into this thing that you then go and tighten down into your actual enclosure. Let's talk about the actual locations that we have off the stuff. We're going to go and have zone 0, which is going to be places where it is continuously going to go and be explosive. Generally speaking, zone 0 are going to be inside of process, inside of gasified areas, whether that's going to be stuff like our gasoline tank that is shown over here, inside of other industrial processes utilizing hydrogen or acetylene, etc. We will usually only going to go and have a zone 0 device that is going to be used for sensing. It is incredibly rare for us to have anything other than sensors inside of a zone 0. Occasionally, you can go and have something on the other side of a zone 0. It would be allowable for me to go and take this tank and to go and place a window into that tank, right? You can have a gas tank, you can look at gas safely. And then on the other side of this window, I could go and place a light. So on the outside shining in so that I could go and actually see what's happening inside there, but that light would be mounted on the outside, which would mean that it would have to be into a zone 1 location. The sensor over here, if I take a look at it, is going to go and be mounted inside of my zone 0 location. And then I'm going to go and have the box, which is going to be on the outside, is going to become a zone 1 location. And then depending upon the type of box, etc., around that, we would still have my zone 2 location that would be around it. We do have very stringent sealing requirements. Anytime that I have a zone 0 location, there has to be a conduit seal right at that barrier. And I have to go and terminate. I have to seal any cables that are going to be coming into these as well. Once I get out of my zone 0, I'm then going to be into my zone 1. This is a zone 1 location here. Zone 1 locations can be tiny, confined basically to a box, or they can be quite large, confined to an entire area of a plant. If it is going to be a zone 1 location, I'm going to have to go and use zone 1 wiring methods, which are going to be rigid metallic conduit. We want that conduit, first of all, not to get damaged and let gas in, but secondly, if there is an explosion inside that conduit, not to let any fireballs back out of this thing. So we're going to use conduit, rigid steel or rigid aluminum, and hazardous location, HL or EX or X type of cables with proper cable glands. This over here is an illustration of my zone 1 location. So I've got a zone 1 location where I'm processing something, and so I can make the assumption that this entire area is going to be gasified for more than 10 hours a year, but less than 1,000 that I'm going to go and have. Anytime that I have got boxes where I have got arc producing components, switches, and things like that, I'm going to go and have to have a seal over here. Underneath my trade size 53 by 2 inch, conduit seals are not going to be required by any of my turret splices and taps like this, but I will need to go and have seals anytime that I leave from the zone 1 over to the zone 2, or if I went from a zone 1 into a zone 0. Obviously, there has to be a zone 0 somewhere out over here, so if I had a conduit, let's maybe not tee it right there, let's take it out of this box over here, I would have to go and have a seal before I go into this zone 0 type of location. We do have allowance that we can use a little bit of flexible cord inside of my zone 1 location, but we don't have a lot of cords. They're going to have to be extra hard usage types of cords that we are going to go and use inside of them. Taking a look at moving from my zone 1 into a zone 2, zone 2 is going to be less commonly, it's going to have less gas that is going to go and be inside of it. So I can go and drop the level of equipment that I can go and use. Since it's not going to happen very often, I can go and have more wiring methods. Even the ACWU is going to be allowed inside of that thing. Because they do still have that chance of explosion, we are still going to have specialized enclosures. Generally speaking, if the type of device creates an arc, so if it's a switch or anything like that, or if it creates a high temperature, transformers, motors, etc., then we're going to go and need to have an explosion proof if we're working off the class div, or flame proof if we're working off of the zone types. But if it has just got a splice box that is going to be inside of there, that splice box would not need to be explosion proof or anything like that. Anytime inside of that zone 2 location that I do have something that is required to be flame proof, so because it's got a switch inside there, we'll just draw a switch right next to that, then I would still need to go and have that conduit seal that is going to be on it as well. Taking a look at migration, we do have to worry about migration. Migration is going to be the movement of gases from one area to another. If I have got a zone 2 area that is going to be outdoors, so some place that's going to be close to like gas fueling places. Gas fueling places, chances of us having a right air fuel mixture, pretty low to slim to nothing, but it could go and happen. So if I do have a terminal box that is going and being placed inside of this zone 2 location, I'm then taking that zone 2 location from here, I'm taking a cable that's going all the way inside of a building. Because it's going inside of that building over there, and the building has got a unclassified, in other words, non-hazardous, negative pressure area. So I've got exhaust fans inside of there. What could happen is I could literally use this cable like a straw to go and suck gas in from this location over here. Just it's going to go and pull because of my fans inside of here into that building itself. What we need to do at that point is we need to go and seal it off before that can go and happen. Just cut off the issue before it becomes something. So you're going to go and have a seal on that type of your cable over there. And as long as your cable is fine for that point through, there's no way that you'd be pulling anything through here. Okay, zone 20, zone 21, and zone 22 are going to be my dust type of areas. Zone 20, 21, and 22 have got more freedom because dust doesn't have nearly the same penetrating abilities as what gases have. We still have to go and rank them for that. Whatever I'm going to go and use inside there needs to be the correct type of wiring method, cable or conduit, rigid, etc., as well as the right type of boxes, but we do have less that we have to go and worry about. First of all, we don't need to go and have the 5 threads that we usually need to go and see inside of explosion-proof for gases, because explosion-proof for gases are going to be lighter, and therefore it's going to be easier to push them to the outside. So we want to have these 5 threads. Normally, now once we get into dust type, we only need to go and have 3 threads that are going to be used. Zone 20, which is our most explosive dusty area, still needs to be rigid metal conduit or hazardous location cables that are going to be used. But when I do need to go and have stuff that is going to leave from my zones 20, 21, 22, then I need to go and make sure that I prevent any sort of dust from traveling through. And there's 2 ways that I can go and do that. I can go and put in a permanent conduit seal, so an EYS that I'm going to go and then fill up with, my Chico sealing compound, something like that. Alternatively, where I leave from my zone 20 location, what I can do is I can just go and have a horizontal chunk of conduit. So if I have got zone 20 over here, I can go and take a chunk of conduit. As long as that conduit is unbroken for 3 meters as I go into here, the chances of any sort of a dust being able to go and tick, 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 travel through 3 meters of pipe with conductors inside of it, slim to nothing. It just doesn't have the pressure. Or I can go and have, as soon as I come down through this one over here, I can have 1.5 meters going straight down, because once again, the chance of dust traveling back up into here is going to be slim to nothing. Zone 21 are going to be very similar to Zone 22. This is going to be a less hazardous dusty area. The additional requirements are boxes, fittings, and joints. That the CC specifically requires all of my boxes, fitting, and joints to be threaded for the connection of conduit cable gland, and that they have to be suitable for that. And then my Zone 22 is going to go and be much, much lighter on its restrictions, tech, ACW, etc., that I'm going to be able to use there. And I can use just NEMA type 4 and 5, which is going to be my sealed types of boxes, but they're not explosion proof, for taps, joints, and terminal connections inside of these. Last of all, I wanted to take a look at this chart over here, which is going to be my class and div. This is what we call substantive, similar installation requirements, meaning that they're very much the same from one to the other. If I go into my Zone 1, over here, I see that would be a Class 1 Div 1. Do note that there's nothing for Zone 0. Zone 0 did not exist inside of my class and div type. It just was said that, that was a place where you can't put stuff without special requirements, and then they started to be like, well, that's a bit of a pain, so we'll just create this Zone 0. So Zone 1 is going to be Class 1 Div 1, class being the fact that it's going to be a gas, div being the fact that it's going to be there quite a lot, and then my Class 1 Div 2 is going to become my Zone 2, class being that it's a type of gas, Div 2 being that it's infrequent. Class 2 is going to go and be dust. So I'm going to have Zone 21 and Zone 22. Do note that I'm also missing that Zone 20 off of there. I don't have a Zone 20. Class 2 is going to be the div that I'm going to have. The div is going to go and be 1. Really take a look at this. This is Roman numeral 2. This is Roman numeral 1. It's a Roman numeral 21 that we have over here. Hey, check it out. Does that line up? Oh my goodness. Crazy. Same with my Class 2 Div 2 is going to go and be Class 2, meaning it's dust. Div 2, meaning it is a number 2. It is a Roman numeral 22 that we have just created over here, which lines up with my Zone 22. Class 3 is going to go and be a little bit different, because Class 3 was dealing with my fibers, and all fibers are classed as being a Zone 22. So Class 3 over here would be Class 3 Div 1 or Class 3 Div 2. Just follow my Zone 22 style of locations. Only other things that are worth taking a look at over here is just the difference between Class 3 installation requirements and Zone 22. Inside of a Class 3 installation, according to my J18, I'll just write that down over here, which is my J18. Inside of a Class 3, I could go and use an EMT. So if I have an old plant, EMT might be allowable. And if I don't have an old one, if I'm underneath a new one, 1 second there, then I'm going to go and have these Zone 22 ones. Inside of Zone 22, I cannot use EMT. EMT is forbidden inside of Zone 22. So newer installation, you might not be able to use EMT. Older ones, you might be able to. Past this, inside of my Canadian Electrical Code, you can go and find all the rest of these specialized areas. Section 20 is going to go and tell us about gasoline dispensing, propane dispensing, specific locations, and it's going to give me some very specific rules that are going to go and follow along with those. Okay. The rest of this now is, that's it for these hazardous locations. I'm going to go and link up a video for you that comes out of the code course where I talk about hazardous locations. It's going to be a longer one that goes more in depth, but it goes through all the code rules themselves that you are going to be testing out of.